Hey there, welcome back. I'm sorry I can't be with you today. We are quarantined, healthy so far and quarantined. So here we are going to do some reviewing today, which is great because it sounded like people wanted some reviewing. Even if you didn't, it's been a lot of days since you've done this stuff. So one of the skills that we learned before break is solving tougher looking equations, maybe such as this right here, by using the zero product property. So before I get to number 68, let's look at number 60. It really could look very similar to number 68, but it's already in factored form. So once it's in factored form, you take the factors. Come back. Here is a factor. It's this factor times this factor that equals 0. So zero product property says if the product, when you multiply, if the answer is 0, one of those factors must be 0. So take each of those factors and set them equal to 0 to figure out what value of v makes that yellow factor equal 0. -6. If you plug -6 in for v in this yellow factor, -6 plus 6 is 0. 0 times, it doesn't even matter what the blue number would be. 0 times the blue value would be 0. What about the blue factor? What makes that value equal 0? It's not going to be -4 because of that 3 in front of the v. 3v equals -4, so v would be -4/3. If you plug in -4/3 here for v, multiply it by 3 and add 4, you would get 0. 0 times the yellow would equal 0. So those are our answers. You can take a nasty looking equation that looks like that, factor it, and then set those factors equal to 0. So like for number 59, what makes this factor equal 0? Well, 1. And then what makes the other factor equal 0? 5k minus 3 equals 0. Set that factor equal to 0. So we have to add 3 to undo subtracting 3. 3/5. There we are. Now number 61, be careful. It's not in factored form, but before you even think about factoring it, make sure it's set equal to 0 first. We have to subtract 6 to get the right side to equal 0. I keep on writing equal signs when I should be writing other symbols. There we go. What you do to one side, you do to the other, so now we have a 12 for the constant on the left side. Now you try to factor this. Notice there's a 1 sitting right there, which is awesome. So we're just looking for ways to multiply to 12 that add to 7, and that goes right into our factored form, so that would be 3 and 4. So to factor the trinomial up above, it would be n plus 3 times n plus 4. Don't forget it's an equation, equals 0. So the red line and the blue line are equivalent. The blue line's what we call standard form. The red line is factored form. Once it's in factored form, it's easy to find what makes the factors equal 0 and what makes the equation equal 0. -3 would make this equal 0. -4 would make the other factor equal 0. So those are the solutions to your equations. Remember, the solutions are on the back page or something like that. You'll find them. Look for the answer key. Do that to check to see if you're right and to either affirm your learning, fix your learning, or get some help. I'm going to skip down to number 65. 65 is nice because it's set equal to 0 already, but remember, man, we got a number in front of the x squared. Always try to factor it out. I can't take a 6 out of everything, but I can take a 2 out of everything. 3x squared plus 2x minus 5 equals 0. And now we still need to try to factor this trinomial right here. And we still have a leading coefficient, but the numbers are going to be smaller, which means it's easier to work with. So we have to take 3 times -5, which equals -15. So if we're doing the split the middle method, we're looking for ways to multiply to -15 that add to 2. Now, as an aside, don't write this up here. I'm just saying, some of you really liked to do the guess and check method. So you'd put like a 3x and an x here, and you'd find ways that multiply to -5, which there aren't many. But then remember, the order that you put the numbers matter. And then you do your smiley face check to try to get this positive 2x there. I'm going to go with split the middle just because that seems to be what most people prefer. So 5 and negative 3 work here, but those are actually your x terms. So this 2x becomes 5x and negative 3x, and you drop down the original stuff. The 5x is positive, so I'll put a plus 5 in front of it. Now we factor by grouping. Sometimes people leave that GCF, that 2 that's out in front, off for a little while. Ooh, let me address this issue right here. See this 3? It's negative, so I need to do a choppy slashy here to make sure I see that 3 is negative. It's the 3 that's negative. Ready? Yeah, sometimes people leave this 2 off. In the end, it needs to be back on there, but it does make factor by grouping look a little more complicated. You can only take an x out of the first 2 terms, and you'd only want to take a negative 1 out of the last 2 terms. Oops, now that changes the sign, so they're both positive and they match. So you get x minus 1 times 3x plus 5. Remember, it's an equation, equals 0. And remember, there's also that GCF of 2 out in front. Now you actually only have 2 variables here. So you only have 2 answers. We'll talk more about that later. X equals 1 is an answer. And then when you set this equation equal to 0 to figure out what makes it equal 0, which will be a solution, you get negative 5/3. So that is the zero product property, getting answers that way. And again, these all stem from having a trinomial that you can factor. Now, sometimes you can't factor them, so that's why the quadratic formula is nice. Or sometimes you can or can't factor them, but you're given a nicer equation that doesn't have an x term. So this is numbers 103. We're not going to do 104, so I changed the problem set. Oh, yeah, we're not going to do 102. Not going to do 102. So 103 to 108. Notice these don't have an x term. They have an x squared, and they have a constant. So you could try to set them equal to 0 and factor. But instead, since I can actually get x by itself, let's solve for x. Let's undo things. So here's where you can list what's being done to the x. It's being multiplied by 81. It's being squared, and it's also being added to by 10. And so now we want to get x by itself. So undo adding 10. Undo multiplying by 81. Undo square rooting. Undo squaring by square root. Don't forget the plus or minus. So we get x equals plus or minus. And now with the square root of a fraction or a quotient, you can break up the square root. So this really equals plus or minus 2 over 9 because both of those numbers are square rootable. So x equals positive 2 ninths and negative 2 ninths. Plug those options back in here for x. Put that in your calculator. Use parentheses around the 2 ninths. You will get 14 out. It is what makes the equation true. Anything else tough here looking? I'll do number 108. So undo the subtraction first. Remember, only if it's in parentheses do we undo, the addition or subtraction towards the end. 4p squared equals 232. Uh-oh, I don't have a calculator right on me. Let's see what we can do. 58. Ooh, is that right? 58. I feel pretty good about that. 58. So then p equals, how do we undo squaring? Square root. Don't forget the plus or minus. P equals plus or minus positive and negative square root of 58, which is about, 7.5. But it's actually some weird looking decimal. All right. That's how it goes. Check your answers as you're going. Take your time thinking about what's being done to the variable and how you undo it, and make sure you undo it in PEMDAS backwards from the bottom up fashion. Alrighty, so we're doing numbers 57 to 68 from the last set, and then 103 to 108. All righty. You go. You got this.